Imagine you wake up at 3 a.m. Not because of a nightmare, not because of your phone, but because you're sweating through your sheets in the middle of summer and your air conditioner just gave out. You stumble to the thermostat, 98 degrees inside. You look at your electric bill sitting on the counter, $340 this month. And you think, there has to be another way. There has to be something humans figured out long before electricity even existed. Turns out, there was. And it worked for over 3,000 years. Stay with me, because what you're about to discover wasn't lost because it stopped working. It was buried for a very different reason. And once you see it, you can't unsee it. We've built our entire comfort system around one invention, the electric air conditioner, born in 1902, a little over a century. And in that short window, we became completely dependent on it. The Department of Energy confirmed that cooling accounts for roughly 12% of the average American household's energy bill. Every summer, that number climbs. Every summer, the grid gets pushed closer to its limit. And most people never stop to ask, what did humans do before any of this existed? How did civilizations thrive for thousands of years in climates far more brutal than anything most Americans experience today? The answer is a cooling system so effective that modern engineers who studied it described it as thermodynamically elegant. It used no electricity, no refrigerant, no moving parts. And it cooled homes to 65 degrees Fahrenheit in the middle of summers where outside temperatures broke 104. Not once, not occasionally, continuously, for centuries. It's called the qanat-connected clay pipe cooling system. And it came out of ancient Persia, modern-day Iran, built by engineers who understood something about the earth beneath their feet that most of us have completely forgotten. Here's the secret. Dig down 6 to 8 feet below the surface, and something remarkable happens. The ground temperature stabilizes. Doesn't matter if it's 110 degrees above your head. 6 feet down, the Earth holds steady at around 55 to 65 degrees Fahrenheit, year-round. The physics is simple. Solar heat takes months to penetrate that deep. By the time summer heat reaches 6 feet underground, winter is already arriving at the surface. The ground beneath you is always running about half a year behind. The ancient Persians didn't just know this. They engineered an entire civilization around it. They built qanats, horizontal tunnels carved into hillsides that tapped underground water tables and channeled water across long distances purely through gravity. No pumps, no power. The oldest confirmed qanat still in operation today is in Ghanabad, northeastern Iran. UNESCO documented it as approximately 3,000 years old. It is still flowing right now, today, carrying water through a tunnel built before the Roman Empire existed. But water wasn't the only thing moving through these tunnels. And this is the part that most history books skip entirely. Persian architects routed these underground aqueducts directly beneath their homes. Then they built a secondary network of narrow-fired clay pipes, terracotta, roughly 2 to 4 inches across, that branched off from the qanat system and ran through the walls and floors of living spaces. Some carried cool underground air drawn naturally through the tunnel network. Others circulated cold water from the qanat through thin-walled clay conduits that radiated coolness directly into the room. The effect was radiant cooling, the same principle behind modern radiant floor heating, but in reverse, and built 30 centuries earlier. Researchers studying surviving structures in Yazd, one of the hottest cities on Earth, where summers regularly exceed 104 degrees, documented interior temperatures holding between 60 and 68 degrees Fahrenheit, while outdoor temperatures raged past 40 degrees Celsius outside. A difference of more than 35 degrees. No bill, no grid, no maintenance window. Here's how the full system worked. Above ground, Persian architects built wind towers, tall chimney-like structures called badges that caught prevailing winds and channeled them downward into the building. The air traveled down, passed through or near the qanat's cool underground channels, shed its heat, and emerged into living spaces as a steady, cool breeze. The clay pipe network in the walls simultaneously radiated coolness from the cold water circulating through them. The two systems worked together. One caught the wind, one used the earth. Together they turned a 104-degree day into a 65-degree interior. Archaeologists have excavated these clay pipe networks beneath historic homes in Yazd, in Kashan, in Kerman. The pipes were real. The engineering was intentional. And the city of Yazd itself is now a UNESCO World Heritage Site, partly because its passive cooling architecture is considered one of the greatest examples of sustainable urban engineering ever built. 44% of Yazd's historic buildings still contain functional wind tower systems, not as museum exhibits, as working infrastructure. Then came the 20th century. Electricity arrived, air conditioners arrived, and these systems, which had worked perfectly for 3,000 years, were abandoned almost overnight. Not because they failed, not because something better replaced them. They were abandoned because electricity was cheap, because modern was fashionable, and because the entire economic model of the age was built around selling you a machine and then selling you the power to run it. For a few decades, it seemed like a reasonable trade. Then came the summers that changed the math. Phoenix recorded over 30 consecutive days above 110 degrees in 2023, breaking every record in the city's measured history. Emergency rooms were overwhelmed, power grid straining, and people asking, quietly at first, what happens if the grid can't keep up? What happens when the machine fails at the exact moment you need it most? The CDC currently identifies heat as the leading weather-related cause of death in the United States, and that number is rising. When grid-dependent cooling fails during a heat emergency, it doesn't fail gently. It fails completely. And that's a problem that no new air conditioner model is going to solve, because the problem isn't the machine. The problem is dependency on a fragile system during the moments when fragility is most dangerous. This is why engineers are looking back. In the last decade, a quiet but serious movement of architects, builders, and energy researchers have been studying and rebuilding the core principle of the Persian clay pipe system. The modern version has a name: Earth-Air Heat Exchangers. Same physics, updated materials. A pipe buried 6 feet underground, air or water moving through it, the Earth's stable temperature doing the thermal work. MIT's architecture department has published research on passive earth pipe cooling documenting temperature reductions of 8 to 15 degrees Celsius in test structures. The Rocky Mountain Institute found that well-designed passive cooling systems in the right climate can cut cooling energy use by 70 to 90%. An off-grid builder in rural New Mexico buried 150 feet of pipe 6 feet underground, connected it to a small solar-powered fan drawing air into his home, and maintained indoor temperatures in the low 70s during 100-plus degree days, using 80 watts of power. A window AC uses 10 to 20 times that. His total installation cost was around $800. The technology isn't new. It's 3,000 years old, and it works. What strikes me most about this isn't the engineering. It's the humility the engineering requires. We live in an era that assumes the newest solution is always the best one. But the qanat-connected clay pipe system cooled palaces to 65 degrees in 104-degree heat, without a bill, without a repair technician, without a single moving part that could break. It worked because it was built in partnership with the natural physics of the Earth, not in resistance to it. The most exciting thing happening in the off-grid space right now isn't a new invention. It's a rediscovery. Modern builders combining ancient passive cooling principles with contemporary materials and smart design are building homes that stay comfortable without grid dependency. Homes that work harder the hotter it gets outside, because they're drawing on the thermal mass of the Earth itself, which doesn't fluctuate, doesn't go down in a storm, and doesn't send you a monthly bill. You don't need to tear anything out. You don't need to go completely off-grid tomorrow. But if you've made it this far, something in this resonated. Maybe it was the elegance of a 3,000-year-old tunnel that's still flowing today. Maybe it was the image of a palace at 65 degrees in the middle of a Persian summer. Maybe it was just the question itself: what did people know that we've forgotten? The future of cooling might not look entirely new. It might look like something ancient, finally understood well enough to build again. If that idea is worth holding on to, subscribe. Every week we go deeper into the systems that got buried, the technologies that got forgotten, and the methods that still work when the grid doesn't. That's what this channel is about. And we're just getting started.